Hey, I think you can hear me. Hello, 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 hello. Hey. Okay. Yeah, I agree with that, viable clan member. Uh, Viable. I'll call you viable. Welcome to the channel. Uh, I agree that there were a lot of mistakes in OOP. Um, but yeah, it's definitely opinion. Okay, Knock, to answer your question, why do I have a web page? I just wanted something visible. Since I'm doing it in TypeScript, I thought, why not make a web page for it? Um, and so I'm just spending a few minutes on that. It'll make a little more sense, and then I can share it more easily. You know, I can just throw it up on Netlify or something to share and show people what I'm working on. Um, and why did I choose OOP? So let's see if I remember how to get back to. Have I considered Dino? Yeah. I have not learned Dino yet, but it's a good idea. Um, I mean, everything that's not React should port right into Dino, right? Except for like I'll have to do something about permissions for reading and writing if I make a CLI version. Sorry, I was trying to get to the book to show you the book Viable Clan Member, but it's crafting interpreters. You got me, Viable. um, craftinginterpreters.com. It's a book. Let's see if I can remember how to navigate buffers. Go here, please. Okay. So this is the book, and it's written in Java. Actually, at the beginning of the book, the author explains, Bob Nystrom explains his choice about using OOP. He simply says that OOP is rampant in the language design space. You know, lots and lots of things are written that way, and that's how he chose to do it. You know, I respect his opinion. He works as a language designer for Google on the Dart project. At least he did last time I heard. So I think both are reasonable choices. Functional, or it is an appeal to authority. I'm telling you why I trust his opinion. I didn't say it's fact. Um, yeah, yeah, yeah. I don't disagree with you. I'm not sure if we're arguing or not. Like, this seems like a thing you say when you're arguing, but I'm not arguing, or at least I don't think I am. Yeah, there is a major advantage to that. Cite all of open source. But also, I'm just learning about this and how to do it. So I found a book that looked respectable, and I'm going to do it the way the book does it. I'm literally just following the book. The only thing that I'm doing differently from how the book does it is the book uses Java, and I'll be using, or I am using TypeScript. So. Yes. Tabs versus spaces. Shall we go there? Derail the stream? Spaces and tabs are both in the ECMA spec. Yeah. I don't know. Is it worth it to you, Knock? Apparently not. Okay, so what I'm doing right now is debugging why I'm not seeing anything. I was hoping to see some output in here. Okay. I don't need this anymore. And, oh, that's why. I wasn't even printing it. Let me see, without changing anything, if I put the output in here, if that then, hey, look at that. Okay, something's, I'm expecting a growing list here, but that does not seem to be what's happening. Tab isn't a character. I don't know what that means. I mean, it's an ASCII character. But so Viable, you said you were Viable, you said you were learning FPTS with Ramda, right? I don't know FPTS. FP-TS. But I respect your hustle, Viable, but I don't. But I don't really. I don't know. I don't really. I don't want to say I don't care. It's not the thing that I want to talk about right now. But I would love to talk about FPTS and Ramda and what you're doing with it, if you're interested. Okay. Setting the output, and I expect this to re-render with the new output. For sure, for sure. Let me write, speaking of tests, let me write some tests for my output. Oh, yeah. No, that all looks right. So let me write a test to make sure that it's doing what I expect. This test will have to change because it's not correct right now. Interpreter. I don't really need to say interpreter at the beginning of all these. Output collects. To test OOP, do I use DI dependency injection? No, I just do unit tests. I mean, I do some dependency injection. Like, for example, JavaScript relies on a global console function. So here I mock the global, which you could think of as dependency injection, right? I'm trading a global for another thing. Usually dependency injection would scoff at the use of a global, but I mean, it's built into the JavaScript environment. So in that way, I'm injecting a different dependency when I mock the global console. But I don't like build my systems that way, at least not this one. It's almost a pure function knock. The thing that makes it not a pure function is that you can run, it has states. So you can run, like if you're running a REPL has state, right? And it's the same interpreter every time. So, you know, if you extract the context or the environment into a different object and pass that environment around everywhere that is needed, then it becomes pure. The same thing with side effects themselves, right? The interpreter itself can produce a side effect. Like, for example, I could write a built-in random function into the interpreter, and that would not be pure. But if I abstracted that idea of the side effect out, for example, like Viable mentioned, using dependency injection or using monads or something like that, like Haskell does it, then the entire thing again becomes pure. Same thing with like network calls. I don't know if it's easy. I mean, I'm sure, everything in an interpreter is itself, in and of itself, pretty simple code. But making that work with everything else, I'm not sure. But I'll learn. That's what I'm doing this book for. Environment is a map, yeah. But monads are really useful for holding on to side effects. And how did MAL make a Lisp handle side effects? Okay. Viable, you said, is this dot pure? Knock is just writing more things, and I don't have that much chat on this screen, but I can see the chat on the other screen. Making testable code. Yeah, I mean, what are you doing on the way to testable code? And you said, is this dot pure? This dot could be pure. I mean, this dot being used in an individual function signals that it may not be pure, but it could be. It could be part of a pure system, a pure function. Especially if you consider this itself is just another invisible parameter. Like I said, interpreter itself has no side effects, only the built-ins. Right, the same thing. You just pass everything in and then it's pure. But that's true of any function. How would you know if... Yeah, you wouldn't know, but I mean, you wouldn't know only by looking at one individual function. But it's a question of scope. No pun intended. But like on an individual level, this dot, on an individual function level, this dot signals that something could not be pure, but you wouldn't know. I mean, that's why JavaScript is not a pure language, right? It's a muddled language. What's the opposite of pure? I want to say muddled. Can we agree it's muddled? Yeah. Well, I'll say what I said before. Impure, evil. I'll say what I said before, Knock, is that making any individual part of an interpreter pure might be easy. But making it all work together like that might require something more than a map. For example, if you produce like a ton of output over time, think about time, right? Like, let's say you want to do something, have an interpreter that, like JavaScript set interval, for example, or write a function that logs a random number every 30 seconds. Scuffed, yeah, I like scuffed. Right, like how would you represent this timed thing, this timed side effect as something pure? Question, food for thought. When you don't consider time, I think it might be easy. Right, you can use a state machine to talk about each individual thing, but what about the concept of time itself? Like this 1000 is a value in JavaScript. And by the way, state machines, and like I think it's true that state machines um, are monads, or can be represented as monads, or you can build a state machine monad. You can just provide the time primitives to the interpreter. Well, no, the thing is that like when you deal with like a random number, for example, is an impurity, right? So you're saying you have to pass the idea of a random number generator into the interpreter. Then the interpreter runs some code and produces a random number using the thing that it got. Okay, now what if I want to say that the interpreter should be running code over time? If you say pass the time primitive into the interpreter, then the interpreter, if the interpreter runs over time, time is a side effect. If it runs over any amount of time, then that is a side effect, right? Because like let's say you have not just a random number generator, but the string get current time, right? Or not the string, the number current milliseconds. Then you could not say that interpreter always returns the same value every time it's run, because it depends on time itself. You pass in the time primitive, okay, but it won't return the same thing at the same time every time it's run, because it runs over, like, in time, in the forward universe, right? I feel like this is a reference I don't know, but it's okay. Right, but the moment that you provide the time things, yes, like you can mock time, but like you can mock timers. I will look at this later. Viables Seme reference. This is org mode, by the way. Knock. I'm sure you've seen it before, but I just put a note for myself. You said you checked it out though. Okay, I'm trying to debug this thing. I'm not sure that I'm making a reasonable argument, Knock, to be honest. So I'll leave it. But I certainly like agree with what you're saying, but I'm not sure how to express why I think what I'm thinking about is different. What's the core problem, Viable? And I don't mind. You don't have to help me. Like this output thing, or the idea of time? Yeah. Well, this whole chat thing this probably doesn't help. Oh, I don't mind. I'm gonna work on my project regardless, and I don't mind getting sidetracked too much. But now, I look down here. Let me refresh the page so this thing stops counting. Then I look down here and I say, oh, it's still broken. Why are you still broken? So I don't know why this thing... Oh, well, I took this out. That'll help. this online chat room that you're in right now. This dot print line. Okay. Test. Hey, there we go. Test. Hey, there we go. A, B, C, D, F, G. Okay. That is what I expect. Why don't we make just a clear output here? Should probably abstract these to somewhere else. This does not need a parameter. I'm glad that you like your joke. Okay, I'll write some tests for this real quick. So output collects. Okay, let's steal this. Whoa. Whoa. We have an interpreter. We have a mock implementation for console.error. I think we can say expect console error mock not to have been called. In fact, we could put this here as well. And here. No, we're not mocking it there. This is Jest, yeah. Which I don't love, but it comes with great React app, so here we are. I can fail on console output automatically. That's cool. I'll check that out, but it's not something I mind totally right now. Jest can fail on console output automatically. I need a new chat window here. This one kind of stinks. Not doing everything I like. Okay. Let's check it out. Oh, dark mode fail. This looks terrible. Oh, this is an NPM package. Expected the test not to call console error. Oh, so you just call it at the beginning? Interesting. So this is what I'm doing right now. Oh, and I'm doubling up. I don't need to test the mock. So I learned two things by checking this out. So I can expect console error instead of this, instead of holding on to this mock. Oh, but I wanted that. That's what I was doing to clear that out. Oh, so the other thing viable is that, for example, here, I actually want console error to be logged. That's what I was doing. I forgot about this. So these are expected errors, and I actually want console.error to have been called. So this is false. I actually want it to have been called. Get out of here. I want it to have been called for this parsing error. Right? This is a parsing error. This doesn't make sense in this language. But I don't actually want it to print out to the screen. So like I want this to be a no-op instead of actually doing the thing. because I wanted to just say test pass without actually showing the error. This does not throw because this is the scanner. Right now it's only doing the scanner so far. And I actually want it to continue scanning and find more errors. So I don't want the whole program to halt. I just wanted to do a nice little console.error and oh, well, the thing is that it's a space, like white space significant language, right? So you can just go to the end of this token like that, like the next white space, and you can continue scanning. This is the tokenizer, right? So it's only looking at, like, for example, in the CSS over here, word, like here's a token, here's a token, here's a token. You don't. You do not. But then it would just, you know, the scanner would just mess up one more time on the end of things. Security issues? I don't think alone that would cause security issues, no. Because, so the other thing that it does is this interpreter.had error. If the scanner, right, the scanner is just the first phase of the interpreter. So if the scanner, while looking at this stuff, finds any errors at all, it does not proceed to run the program. Thanks, Knock. I'll check out your game later. Good talking with you. Happy New Year to you if I don't see you. See you next year. Okay, so what was I doing? GG. Okay, what am I doing? This is not true. I don't really care. I don't care about errors here. I don't think. I mean, I could say, I could do this, which we just learned. Just say, you know, not hide them, but say expect console.error not to have been called, as we just learned, and that'll be fine enough. Okay, and then I want to run a valid thing, so like test ABCD EFGH, and then I want to expect interpreter.output to be the same. What about alert? I don't have any alert in my code yet, but if I add some, I will certainly test for that. I happen to only be calling console.error right now in the error catching code. So I expect this to be this, or maybe I think I might expect it to be have new lines instead, but we'll see that in a second. And then I want to say is that the end of that sentence, or is there more to that question? I'm not sure I understand. If I do this and I say test2, then I expect the output to continue, right? Because it has state. So I expect it to be that plus this. And I'm only doing this for my own, separating it like this for my own clarity. Can't see dogs. Can't see Dodd. I read this. I said dogs. Let's see. Okay. Oh, this is Oh. So this is, I think I've read this article before, and it describes how to test implementation details for a UI. But at this moment right here, I'm not actually testing a UI. This is the internal interpreter code. So I'm not testing, this is not React, this code. This is the interpreter in just TypeScript. Okay, let me look at the tests. Okay, right now it's printing more stuff than I expected. Is that wrong? I don't think that's wrong. This test isn't going to last because this stuff isn't this isn't like the end goal for behavior. But I'll just make it happy right now because I want to see. I'm just using this test as a, you know, helper. Okay. So does that, oh, EOF too. And you still don't like that because of this new line here. Are you happy now? Right, okay, so I got past the first one, and now I get the same thing again. So let me do this, and what does it do? Goes to the first EOF, and then the second one. And this is test 2. Okay, that passes. So this test is not going to last for a very long. Definitely. But that was helpful to see. Okay, now I think back in my UI code, app.tsx, I'm not actually doing testing on the UI because I don't care about the UI that much, and it shouldn't be very complicated. Much more interested in the internals of the interpreter. I don't actually need this output variable at all anymore. Well, wait. No, I need to hold on to the interpreter itself. Or I could just hold... Yeah, I think I need the interpreter itself. Interpreter, set interpreter, but we won't be setting it. We'll just create a new interpreter here. And that'll be our interpreter. And run does not exist on type string. Well, that's not right. It's an interpreter. Gosh. And then we don't need to set output. Instead, we can just get our interpreter. Interpreter.output. I'm going to have one of those things by the end of this where the word interpreter doesn't make any sense anymore. Okay. You don't seem to like that at all. Something's not right. Should a new interpreter be inside of a use memo? Yeah. Actually, I think use state just allows you to do this. And it doesn't need to be, this function will only get run once, even though this function gets called all the time. This function only gets run once. So I think your intuition was spot on. I think you can do this. I might be talking out of my hoo-hoo, but it's still not working, so something's not right. And we don't need this source variable really. We can just flip these around. When the user hits enter, then run the code. Come on, editor. Be nice. Okay, so that, whoa, I don't know why that caused a change here. No, it didn't. Something else happened. Something not quite right. How could I figure out what's going on here? Interpreter.run. I could console.log interpreter.output. But I don't think, see, that's so weird. When I save here, the hot refresh occurs and output, oh, output needs to have its own use state. So that, because, yeah, which I just had. So I don't know why I'm writing this again, but I am. So because come on. Okay, default output text. It'll start with default output text. So if I refresh this, no, I need to do some more work. Output here. Okay, now I have the default output text, and now here where I'm console.logging input.output interpreter.output, which I think should work. Yeah, so the console.log works. So now I just need to change this to set output, because update the output state, because React needs to know to re-render. Okay, so now we should be doing better. Yay, we're doing better. Now this should have new lines in it, but they are not respected. Oh gosh, look at this cramped thing over here. There should be new lines in here, but they're invisible. Oh, you can see them when you double click on it like this, but you can't see them in here, which is interesting. So we just need to make that in our CSS. We can make that be, I forget how you do this, like white space. Is it white space 3? Yeah, look at that. Okay, let's write some more. Hey, look at that, one more token. And then if I write like ABC, okay. Now we can make a couple buttons real quick. Where do we want to put those? We'll just make a new div. And a button. What is my mode right now? TypeScript mode. So I want to be in TSX mode. Okay, that's better. Although the whole formatting is different. That's not good. But it'll be fine for now. Button, we'll say this is clear, and we'll say on click equals interpreter dot clear output. And then we can, have a button that says do this whole thing. So let me abstract this whole thing into a function, run code, or run, I don't know, run source. I don't know. Names are hard. And run source here, and run source here. Oh, this is an interpreter function. Run source. Cannot find name L input. Oh, okay, that's here. So I just need to copy this here. Okay, so we have a clear button. It's not happy. Oh, I need to re-render after that. So let me make this, what do I want to do? Clear output, make it into a function as well, because I need to do two things. Function clear output. I need to clear both the interpreter's output as well as the UI's output. Okay, that works now. Cool. They both say clear. Let's make this one say run. Oh, that didn't work. Now if I write, instead of pressing enter, same thing. Okay. So the UI looks pretty reasonable now. It's obviously not printing anything sensible. This is just the information from the tokenizer. But what? Back to the book, I guess. I think I might shake out and take a break at the hour mark here. I'll be back in a few minutes if you want to hang out. And if you are lurking and you leave, thanks for joining. And I'll see you soon, but I'll be back in just a couple of minutes. That's not what I meant to do. Right, back. So I'm gonna go back to the book where we were when we decided to take a long break to do some TypeScript. And check this out. Might even get rid of this for now. Oh, I want to check my tests as well, and I should probably... Yeah, okay, test passing. I should probably commit all that. So let me see what I did here. I formatted the HTML. I changed the main to root. Or I changed the root element to a main instead of a div. I wiped out the CSS. Added new stuff. Deleted the app test because I'm not going to do that. For right now, at least. And I implemented the basic interpreter in the UI. Okay. I added some tests for output, and I added some output functionality. So let me actually commit the output functionality first. And then since it's a dependency for the application. What did I do in tsconfig? Oh, that's part of my attempt at making a CLI out of create React app that didn't go well. Okay. So I added, make sure that's it. Yeah. Add output commands to interpreter. And collect, I don't want to say this. Collect output, all output as state in the interpreter. So that I can do all this stuff. Basic REPL in HTML. I'll just say in React using the interpreter. Okay, this stuff I don't care about. Could stash it, but it's not very much. Okay, back to a relatively clean slate. Let's see what's next here. So we were just learning about context-free grammars, and now here we're going to talk about how to implement them. Yeah. Okay, so in this context-free grammar, there's this shortened idea of number and string. But we already have implementations for those in the scanner, so not a huge problem. This is ambiguous. Try using this grammar to generate a few expressions. Can you make it generate something wrong like this? I don't know, can we? So an expression is a literal, unary, binary grouping. Literal, it's just one of these. Unary, it's one of these, but it can be something else. So you can do like minus, 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 minus 1. Or you could do minus exclamation point, minus exclamation point, minus exclamation point. Is that wrong? I don't know. Maybe not. We have expression, operator, expression. I don't think there's any white space in here, so you could make it do like... What could you make it do? I'm not sure. Not sure. But the author says it's ambiguous, so trust that. Okay, that expression grammar is our skeleton. Grammar is recursive because they have expression. You can loop through expression, unary, for example. So we'll have a tree, and it'll be a syntax tree, specifically an abstract syntax tree. Definitely heard those words before. So the difference between an AST and a parse tree is that a parse tree, every single grammar production becomes a node in the tree. An AST elides productions that aren't needed by later phases. I'm not sure I totally understand that. Maybe we'll figure that out. We use a single token class. We had a token type enum, yep. Syntax trees are not so homogeneous because they have expressions as well as they have expressions of different contents, right? They're not all just tokens. Like a unary expression has a single operand to track, so that's how many children. I was looking for the word. I was gonna say leaf, but they don't have to be leaves. We could mush all that together into a single expression, but we'll use different types because the author likes Java's type system. Okay, so they're going to use polymorphism here for expressions. I'm not sure that I'm going to use polymorphism. In fact, it doesn't sound very nice. I might do it just to follow with the book. Something weird was happening for a second. I wasn't able to scroll. I was worried my whole UI had crashed. Okay. So, we have a base class for expressions. For each kind of expression, we create a subclass that has fields. And we get a compiler if we say try to access the second operand of a unary expression. Yeah, but I think we could just get a type check error instead, and that would be fine. Like we could say this is of type unary, and so it should only have I'm not exactly sure, but we'll see in a second. Okay, so this is the class expression, and it has static factory methods. Oh no, it has static classes. Oh, this is a Java thing I don't think I'm familiar with. That this is a static class composed within an abstract class. That's interesting. I don't think I know about that at all. Also, the fact... Wait, is this like a static field of expression? So like expr.binary is this static field that has this whole value. Because in Java you can't have multiple top-level class declarations inside of a single file. That's interesting. Okay, so this is telling, like, there's no methods on the expression class. They're just data, which means that in TypeScript, it's probably a better idea just to have types for different object literals. It's probably not useful to have separate classes. Oh, I wish viable clan members still here. the author is agreeing that making classes for all these things is kind of ridiculous. Oh no. Are we writing... Instead of tediously handwriting each class definition, field declaration, we'll hack a script that does it for us. Uh-oh. Oh no, it prints out Java code. Oh no, I don't want to do that. We're not going to do that. I'll just write some types. Okay. I got the idea of scripting the syntax tree classes from the creator of Jython, Java Python, and Iron Python. Okay. Excuse me. So far this does nothing but print out the usage. Oh no. Oh no. I do not want to do this at all. So it takes in base name and a list of types. Right now it's only using the base name. So we're splitting multiple times. No, that's just one split, but getting two things out of the same split. Okay. Oh my gosh, look at all this. I'm definitely not doing anything like this. We'll just describe types and we'll have them. I don't mind copying it to have lots and lots of different types. This apparently is all of them. Okay. So this is the type and these are the fields. So I could do this now. Interpreter expr.ts. Call this expressions too. Or just expression. No, these are really expr.java. These are really nodes in a tree though, right? But the tree is expr. Excuse me. So why don't I call this ASD node.ts and we'll say export binary. We're going to say export type binary equals an object with a left, which is an EXPR. We haven't said what EXPR is. That's fine. A operator, which is a token. Not TypeScript's token, but I think it's going to be our token. And a write, which is another XPR. Now, I think we can just say export type EXPR equals an empty object, and then say that this type extends EXPR. No, that's not. This is not the right syntax. Can I say it here? No, that's not right. How do I say this? I mean, I know how to do this with interfaces, so maybe this is better. Export interface. Like that. Okay. That seems to work. And then I can just copy this, paste it a few times and edit them. That's not what I wanted. Okay. So we have grouping as a expression as an EXPR. We have literal, which is value of any. Well, not exactly any. I'm not sure about that one. And then we have unary, which has a operator token and a write. Cool. Okay. That's a lot simpler than all that business. So the interpreter needs to select a different chunk of code to handle each expression type, right? Not exactly sure where the author's going here. So I guess we're writing some behavioral code for the tree that we haven't yet built. We just made types for it. So a design pattern for an interpret function, abstract interpret function on EXPR that then each of these, we'd have a class for each interface and explore that ourselves. So it scales poorly because the tree is going to be used in different domains, like scanning or parsing, then optimizing, and then name resolution. So then we'd have different, yeah, a violation of separation of concerns. Okay. I feel like, no, I'm not sure where we're headed here. Dynamic dispatch, right? Pattern matching. Hmm. That's interesting. This whole thing has a name, apparently. Right, so if you solve both of these problems at the same time, then you sacrifice something, either static type checking or separate compilation. I'm not sure I understand why that is, but maybe as I go through my language learning journey, I will understand that better. The visitor, not dynamic dispatch. All right, I think I'm going to take another break real quick. The half-hour mark. Try to stay fresh, keep rolling. Be right back. And we're back. Okay. So we're going to solve this problem with the visitor pattern. Keep all of our tests running. Most widely misunderstood pattern. It's not about visiting. It doesn't have to do with traversing trees, but that's a coincidence. It's really about approximating the functional style. Let's just add new columns, which are methods, or method-like things, operations on a class. We can define all of the behavior for a new operation on a set of types in one place. Say we have two kinds of pastries, beignets and crullers. Now I'm learning about beignets. Okay. So we have an interface which knows how to visit both types. Overloading is statically dispatched, and so too are these statically dispatched. JavaScript does not support overloading, so thank you. I wonder if TypeScript could reasonably implement overloading. Probably could, but the code that it outputs would look very weird. And when you add like the rest parameter, it's probably particularly strange. So I can understand why they wouldn't want to do that. Okay. Each operation that can be performed on pastries is a new class that implements that interface. Okay, so the operation is a class. It has a concrete method for each type of pastry. Right, because this is an interface, so it has to implement for each of these, although it might do nothing on some of them. All right, so given some pastry, how do we route it to the correct method on the visitor based on its type, polymorphism? So pastry has an accept method, and it accepts a pastry visitor. So this is abstract. And then, okay, so the visitor object has the implementations on it, and the classes themselves tell the visitor when it is accepted how to, or which method to call. So it's kind of like separating the responsibility, or flipping the responsibility, giving the responsibility of figuring out which part of the class. Confusing. Okay, so types here may not be sufficient. Because we're going to have to implement classes anyways to do this trick. Can you create classes dynamically in JavaScript? Because I could basically write what he wrote that prints out a Java file, but it just runs here and generates the classes. I think you can do that. Yeah, because you can have anonymous classes. So I can assign those anonymous classes to a thing. I don't know, let's think about it some more. For each type, we have base name, which was expr, and then we have the list of all the types, which are here. So this will generate like a thing that returns a type R, and the method name will be called, visit grouping expr. Hmm. So he's able to automate all of that. That does seem appealing. So I'm just scanning ahead now. I want to check out, is this what I expect it to be? So this is AST printer implements visitor with the return type of string, and has a method print on it, which calls the accept, which dynamically dispatches on all of the different things. And now all of these things, and now we'll implement the visit functions. So if you're going to visit a binary, you want to parenthesize the operator, the left and the right. What I don't see, which I expected to see, was a recursive visit. Here's the recursion. It's in this parenthesize. And it's building a Lisp-like string. I missed that. This is the recursive step. So it doesn't have to do with trees because we don't have to recurse. I see. Okay, I'm beginning to be convinced that this dynamic dispatch visitor thing is looking pretty cool. Let me think about how I would implement this. I didn't really love the string representation that he presented and parsing on those strings. Okay, so that's the end of the chapter. Let's go back up to that string generation code, the beginning of it, and see if we can do something similar but using Java's superpowers. Okay, here it is. Right, there's the basics of it. Okay, here's what he has. Okay. So what? You know, I'm thinking if we're going to be doing closer to what the book is doing, let's call this function expr.ts. And maybe we should write some tests first. So we'll say describe okay. Describe expr so when we import expr from that file, what do we want out of that? I don't think that we're going to be able to export all of the things individually because they have to be dynamic. Maybe we can though. Right, we're describing this. This is a textual description of all the things that we want to construct. But since we're doing it dynamically, there's no reason not to make that description in code. Like, for example, export binary equals create or define AST node, or I don't know. And then doing slightly differently from the author does it here. We don't need output dir. We do need a base name. Okay. Although so far they're all going to be the same. Maybe we'll have different ones at some point. And then, you know, we only need to describe this part now. So it doesn't really need to know about binary. Although, actually, to do that textual code generation that it was doing, it would need to know that. But would it? So like we have a class, you know, we can also write like, let's write an example one. So let's get rid of all this, thinking that we're going to be generating that, and we'll say we have an interface. This is going to be a class. It will extend a class, an empty class so far, called the XPR. We can call this an abstract class. And then it has these things I think are supposed to be, oh no, those are types now. So that's correct. We wanted to give them initializers. We'd use equal sign. And then it'll say something like constructor left has to be an EXPR. Operator has to be a token. And right has to be an EXPR. It's called super. And then it'll have to set. So there's a lot of duplication here already. This dot left equals left, and similarly operator, oops, and right. Okay, so there's triple duplication already, so this is a good sign that automating this is a good idea. Let me write a test that okay, it can construct a binary expression, and we can actually export here. Whoa, not that. Import binary from EXPR. I think I'm getting spelling errors. Dictionary add to add word. Okay. So get rid of the spelling errors. Can construct a binary XPR. Expect new binary. We need a base expression to in order to test this creation. So let's say export class what? Unit, I don't know, extends XPR, and it does nothing. Has nothing, does nothing. It's just a concrete implementation of an empty abstract class. So here we can import unit and say new unit and new token. What does token want? Token wants a token type dot and, sure, as well as a lexeme. We'll say and a literal. Don't need anything for that, and a line 1. And then another new unit. Okay. Let's see how that works. Unit is not a constructor. Does it need a constructor to be valid? Okay, that passed. So expect that let's get this out of here. That's huge. Or we'll call this our expr. Const expr equals this craziness. Uh-oh, where did it go? Oh no, I lost it. Uh-oh. Something's going crazy. Emacs is being weird to me. Const expr equals this. Okay, got that. We don't have a unit in there. And now in here, we can say here to equal what? To equal left is something, and basically an empty object. Right is just this new token. I mean, I can just copy this whole thing. Use that. No worries. And right is an empty object. Oh, this is not right. This is operator. Okay, that passes. This is boggling my mind, so let me just separate this out a little bit. Okay. So this is passing with our basic thing where we made it for ourselves. Now we want to generate that using this. So we'll use this as a template. Bring this down here. And how can we generate this whole class? So let's also start writing our function define AST node. And we know it takes a base name, which is a string. And we know it's going to return a class that extends EXPR. I wonder if we can also get that as passed in. Like, is this valid? Type that is not a constructor function type. Can I say function? The function is not a constructor function type. Can I say constructor? Function? Function constructor is an interface. It seems to be built in. Okay. So now we want to pass in EXPR. EXPR is not assignable to function constructor. This is going to be export const. Okay. So you don't like this. Can I call this like class type? No, that's from React. Class expression? Class declaration? That's not a constructor function type. Seems to be a lot of options here. Class static block declaration, class expression we just tried. Or did I just try class declaration? Let me try class expression. You happy? You're not happy. I guess we can try this later. Or we can just say, let's make it type EXPR right now. Oh, you don't even like that. Huh. Oh, because that's not the... Right, that's an instance of EXPR, not... Okay, that makes sense. So... Okay, we're not going to try this right now. So I don't know how to do it. And it's not critical to our immediate goal. Oh, look at these things. Don't need you. Token. Token will be used shortly even. So now we could describe all these things as an object. Well, so far this is a class, but we need to get it type. So I guess I could say type of, right? Like, let me just bring this up here. Give me some space. I just want to transform these things into an object. Okay, so here we have an object. And let's bring this, whoops. Bring this up here. And what this is types, or types is a bad name. fields, and that's an object with strings for indices. And what's on the right side of this? They're types. Is there like a type interface? This is interesting. Does that satisfy that? Let me keep going here. Type of. Okay. Let me get rid of these so I just see, or they're all the same. String is not assignable to type. Type. So this doesn't like this. Now, type of expr is missing the following properties from type. Flag symbols get, okay, so that's not right. What is type? Type is a class. What if I call this, oh, I was never able to do this, right? Right now, let me get rid of these two. So I'm just looking at one right now. One error. expr is missing that class element. Oh, you don't like that? Class element brand. Class type. T extends React component. Definitely not what we want. Class what? Class expression. What could we ask Google to figure this out? And does it really matter? And this is the advantage of doing this stuff as strings. So we don't care what that stuff is. What if we just say any here for a second and keep going, and maybe we'll discover something. So return class. Now I want to say instructor takes in what? I have to call soups. Can we use arguments? And I'm realizing that these have to be ordered correctly for us to be able to create it correctly. Or I feel like doing this without strings is just going to flex my understanding of TypeScript and then ultimately fail it. And so I'm now thinking I should just go the fields or the string route. Wrap this in a string. Say this is a map from string to string. And then return an eval. of class extends base name. You can basically just copy and paste this, but I think it'll be easier this way. Then fields, I can say entries here, const field entries. I think I'll have to iterate over this several times. Object.entries fields. So here we have, let me get rid of this. We have field entries dot for each, and we have a property name. Name is deprecated. That's not what I expected to see. I don't think you know what you're talking about here. Okay, now you're better. Oh gosh, formatting is going to be a nightmare here. So for each field entries for each, I guess I can do this outside, build up this thing outside, and say const what is it? Member declarations. And then here just put member declarations. Here it can say can start the constructor and put in here constructor arguments, or I guess parameters is more accurate. Then inside the constructor, I will have the what? Let me look down here. The member assignments. Member assignments. Okay. So member declarations, they look like this. We have to get from this. I guess I can fix this. Get from here to here. So we have name and we have type. And we want to, what are you complaining about? Oh, I spelled this wrong. Field entries. With each of these, we want to just return this string, simply return this string, name, colon, type, semicolon. And then we want to join on a new line. Okay. We're missing a paren there, or no? For each. Oh, this should be. I wanted this to be math. Okay. So that's step one. Then step two is constructor parameters. Oh no. Constructor parameters. And it's basically gonna be the same thing, but just joined differently. So we want to join these on a comma and a space. How about? Why not? And you know what? That's the same. Because that's just the type. You know, I'm realizing that types are not going to matter here because this is post. These are being created post TypeScript. Actually, the member declaration might not matter at all. In post TypeScript world. Well, we'll just leave it and we'll fix that when we get our errors. Okay. What don't you like? Is this spelled wrong? Yeah, that's fine. Okay, const member assignments. This one will at least be slightly different, but I'll just grab this. We want this dot name equals, and this is just name again. And okay. We also need the super call. Always call super. And this is really the base type, but that's fine for now. Let's see how badly we fail here. Identifier member declarations has already been declared. I did fail to change a name. This is member assignments, please. Now, unexpected token extends in a very strange place. Define AST node, line 39. So we're doing something really strange with eval here. So I'm guessing that unexpected token extends. Let me think about that. I might have to look that up. Oh gosh, I might have to take another stretch break too. Yeah, let's do that. Get hyped again. This is kind of cool what we're doing. I'm kind of excited about it. But okay. Taking a stretch break. Be right back. What are we doing? So I'm dealing with this business here. What I want to do is bring this into, oops, that's not what I meant to do. Oh, that's going to be annoying to now fix this whole business. One moment. Let's hope that's back to where it should be. Okay, that seems right. Okay, what I meant to do is open Chromium and mostly I just want a this guy. Let me pop you out. No, pop out. This one. Okay. So I have this business. Now that's obviously going to error. So let me just play with eval for a second. 5. We get back the number 5. Good. What about class? A class expression. Unexpected token. Okay, so we can both assign to the current environment and make an anonymous class. That's what that test says. Good. Now what? Now I want to test if I make a class out here, if I say B, and then I say this extends A. Okay, that did work. That's what I thought the error that I was seeing here was. Unexpected token extends. But I am not setting this to a variable here. Okay, so this needs a name. So let me give it a name. That's not what I meant to do. I meant to say binary here, and then last name is a string. And now here, I say class name and formatting's a nightmare again. Okay. Unexpected identifier. Where would the unexpected identifier be? Maybe it is, maybe now we're running into these errors. So let me try getting rid of the types here, because I suspected we don't need them. Unexpected token, semicolon. Right, because a parameter does not need a semicolon. Binary is not a constructor. So for some reason, I mean, what are we getting back here? We should expect to be getting back a function, because a class is a function, right? Let me go back to Chromium and say, what is type of A? It's a function. And what if I say new B? That's a constructor. So why are you so unhappy Binary is not a constructor. I don't know why that would be. What is the type of binary? Maybe we declared the constructor incorrectly. Constructor parameters, this. Why don't we print out this string? Const source for our class. Whoops. Class source. Really glad that has not completely gone crazy. Class source. And then let's console.log class source and just see what it gives us. Okay. So as expected, the formatting is not quite right. This is a constructor. Did I spell constructor wrong? No. So what if I eval this and just grab this, go back to Chromium, and just eval this whole thing? We've got a, okay, eval that. Class name is not defined. Well, wait, no, I wanted to copy this time. Eval this whole thing. EXPR is not defined. Okay, let's say EXPR equals abstract class. No, you don't like that. Abstract class EXPR. Why don't you like that? EXPR equals class. Okay. Now, when we eval this big thing, we get something. Is binary a thing now? Binary is not a thing. And we got back undefined. So that's interesting. That's interesting, because that's different from up here, where we had B equals class something something in here, and B became an actionable, a usable thing in this scope. So what if we say B equals that? Well, now we got something back. That's so strange. So just by saying B equals, come back. Just by saying B equals, something was returned to us. So could that be the entire problem? That's so strange. What if alternatively I make this declaration, right? And then at the end of it, on a new line at the end of the class declaration, and then I say binary. So that's an expression. Okay, that's the trick, is that at the end of this declaration, I then need to say class name. Make the final thing in eval should be an expression. Put this up here. Final thing in eval, final. So that the return value is our statement class is the class we just defined. Hey, look at that. We passed our test. Okay, let me get rid of this console.log. Okay, now this is not quite as simple to type as this string representation, but it's better formatted and it's all JavaScript. So now we can write a bunch more of these and continue on and basically do exactly what the author did. So let me write about that too. So I'll say difference from the book. Instead of writing a new file with all the class declarations, use JavaScript's, use eval to generate all of those classes at runtime. Where do I put this comment? Probably here. Now, useless unit is a useless concrete child of expr for testing. Okay. I mean, we could even generate unit here. That's probably a better idea. Let's generate unit. Export const unit is define AST node. Always going to be expr here. Then unit and then an empty thing. We give this some space, get rid of this, and hopefully our test still passes. Good. Okay. Cool. All right, all right, all right. I mean, that's pretty slick. Pretty fun. Okay, so what else does the author do? The author implements the visitor trick. That's why we ended up going to the dark side here anyways. So read about the expression problem, visitor pattern, get back down to where, okay, define visitor is right, writer. Writer is a print writer. Oh, that's the output to file thing. We won't need that. We will just need, I wonder if it's all compiled together somewhere. No, it doesn't seem so. interface visitor. Visitor interface. Struggling to understand where this is. Abstract class base name. Oh, this is up here. So it's like interface visitor for R. I mean, why isn't this called a EXPR visitor? I'm gonna call it that. Don't know why the author would choose to call it. Oh, because, right. So it's under the EXPR base class. So I guess we can do that too. Right, this is the EXPR file. So EXPR.visitor will always have this similar property. Now for each of these, oh, so here's where, okay. So here's where there's a huge benefit to having these all in one data structure is that we get all this for free. Okay. Well, I mean, I can compile this into a whole, you know, just one data structure and then loop through it. Because we're going to need to loop through each of these in our visitor class in order to make the visit functions. Which is going to be another generated thing. So, okay, first let me make the conversion to one giant data structure for all these things. And then I'll come back. So we need one function called define AST, exactly how the author does it, that takes in a base name and then a big object with S in string for its indices. It might end up being that string here is actually like we have an actual type where we list all these types, but maybe not, because then we'd have to put that in two places. And I realize we're losing all the benefits of TypeScript here. I wonder if that's going to be, how big of a problem that's going to be. I mean, what does define AST node return right now? Missing some things before TypeScript will be happy with me again. So this is going to take this. It's going to have a class name as a string, and then a fields, which is this whole thing. Should probably put these in a type. Okay, and you're really not happy here. Hold on. Yeah, let me just start by abstracting these to a type. So type class name is string, and type fields. Hi Equilibrium, welcome to the channel. So the S in string, so what that's saying, and it's all red right now, but this one is working, or it's at least not erroring. So what this is saying, this is TypeScript. Are you familiar with TypeScript at all? This is saying that fields is an object, And all of the, okay, so TypeScript adds types on top of JavaScript. So here, like, you know, the function part you'll be familiar with, and then this is where you'll start to get, you know, wide-eyed, because there's, you know, this extra thing here, colon string. So, but that one's pretty simple. This just says the base name parameter should always be of type string. Here, we could say that if I put just this, it would say the fields parameter is of type object, but it wouldn't tell us, there wouldn't be any additional information about what the stuff in that object is. So when I put this in, this is, I forget the technical name for this, but it's basically the index type. And you're saying that all the indices on this object are all going to be strings, which is the normal thing. It's actually kind of annoying that you have to do it all over the place in TypeScript. And then all the values for all the properties are going to be strings as well. So it's an object from string to string. And this is a valid example of that, which is just a normal JavaScript object. So yeah, let me know if that was super confusing or if it made sense. And right now I'm just abstracting those types because this is all getting so messy. Yeah, no problem. How are you doing tonight? So, okay. I'm just going to abstract all this out here. Right, this is missing a name. These are going to be the... Oh, this should actually be an array? No. What should these be called? What does our humble author... So since you've just hopped on board, I'm following this book called... Oh, you worked through this book already. Very similar to Java. Using TypeScript seems like a much bigger undertaking. Well, I use TypeScript for work, so hopefully not. Cross my fingers, right? It's definitely less similar to Java. So what I just did, if you're just joining, or what I'm working on now, but I've just completed my first test of it, is, do you remember in the book how you write this thing that... Here, I'll just scroll up to it. You're in this chapter, we're writing this generator for code, for Java code. So, like, you write this thing that creates the Java file that's used as input for all the classes, for all the EXPR expression nodes. Let me know if you remember that. If not, oh, and thank you for the follow. Yeah, metaprogramming, right? Okay, so what I've done is a little different from that. Instead of writing a script, a completely separate script to output that stuff, what I've done is use JavaScript's like eval superpowers to create those classes at runtime. So I'm basically doing exactly what the author's doing, but instead of making a separate script and a separate file and having this pipeline, it's just going to do it at runtime for me. And maybe someday, you know, I think it would be pretty easy to abstract this to a different file if I wanted to later, but for right now, I'm much happier to not have that kind of added complexity of having to remember to go, you know, run the other script every time I change this file. So I'm really happy with that solution. Yeah, eval's really cool. I mean, I have to say, you know, like, disclaimer, tell me if you've heard this before, but like, the general rule is don't use eval. This is a really specific use of eval, and I hate to say this like this, but I'm a trained professional and you should not try this at home. Like the reason I know that it's safe to use eval here is because I know why eval is wrong. So again, tell me if you know what I'm talking about and you've heard that before, or if you want me to explain more, I'm happy to as well. Okay, so I wish there was an easier way to write this because it's so gosh darn yeah. Class name is of type class name. I guess I should change this to capital letters. Would it be possible to just use plain JavaScript objects? Yes. Yes, it would have totally been easy to use plain JavaScript objects. What this does that's different from using plain JavaScript objects is it gives me a constructor so that I can make new ones and have yeah. That's all I can think of at the moment. Let me think why else it's better. I think that might be it. Right? So you're going to see that I am using plain JavaScript objects, and I'm basically transforming those plain JavaScript objects into classes. I don't know that I have a better explanation for that. Yeah, I think that's I think I answered that question. I think that's what I was thinking you were asking. So maybe I don't understand. So basically I'm taking this basic JavaScript operation or JavaScript object as a description of the class that I want, and I'm making it into a class. What JavaScript objects, like what I think you're talking about are like object literals, like this. A is 5, B is, apples, right? And these things are super flexible. And I'm actually using, object.entries to iterate over each entry. And then, each key value pair, I'm iterating over them and I'm generating this code. I don't think there would be an easier way to take this and turn it into a function that could generate more of the same thing. Yeah, well, specifically, so look at what I'm evaling. So eval simply runs the code, runs the text you gave it as code. So this is all one long string here. What I happen to be doing is in that string, I'm writing the syntax, the JavaScript syntax, to make a new class with a dynamic name, right? This name is a passed parameter that extends another name that I passed, but these are all strings, right? So these all have to be cool. I'm glad you like it. Yeah, so it's exactly as the author has it. It's like just saving you from a bunch of typing, right? But the difference being that I don't have to do that pipeline thing. It's all at runtime, which I'm super happy about, at least for now, right? Maybe later I would rather have those two things separate, because obviously there's a performance hit now on every single load of the interpreter. But I'm thinking that performance hit is not huge. That's my hope. So what did you think of the book? That's so cool that you did it already. I didn't know, you know, you're the second person, like somebody else in the chat earlier was like, oh yeah, I own the hard copy of the book. And I was like, whoa, I didn't know this book was so popular. That's so cool. Okay, so I'm gonna pass in this object now. So what I'm doing is transforming from, I had each of these as a separate call before, but now I'm gonna write one call to define AST instead and pass all of them as one big object together. So the base name is still expr, and then I'm just gonna throw these things in as, oh, you know what? I'm gonna lose my ability to do a static export of each of these things when I do this. Awesome. You know what? I'm gonna make a note to myself to pay for these books because I've only ever done them online. Like I've only ever done them exactly like I'm doing it right now, and I've never had a reason to pay for it. But I love those books so much, including the game programming one, the design patterns and game programming patterns, game patterns. I forget what it's called, but yeah, I agree that he's awesome. Yeah, really cool dude and really great instructor or writer, or maybe both. Good question. I'm planning on using Rust, which is something that I'm just learning. But that'll be like the big, a big challenge, I think. I'm just learning Rust. I did Advent of Code this year with Rust a lot. As far as I could get. Probably the same. Maybe I could have gotten a little farther with JavaScript. Yeah. I think it's going to be really challenging. Maybe a strain on my brain, but I'm pretty excited about it. And then, maybe if it goes well, I'll compile it to WebAssembly so I can compare the two. So right now, I've actually got, oh, well, it has a compiler error right now, but I've been making a React application for the interpreter so I can kind of share it out. And so maybe I will compile the Rust version to WebAssembly and then be able to compare them in the browser, which would be really interesting. Level manipulations. Oh, low level manipulations. Yeah. I don't know. You can definitely write binary. So like you can, write arbitrary memory to a data structure that you have made. You obviously can't write arbitrary memory anywhere in memory. That's kind of Rust's thing. But if you own the memory, then you can mess with it all you want. So like, for example, a heap and a stack, those are things that would be data structures in my code that I would be, deciding on the ownership of, and I could mess with those as binary as much as I like. As far as like pointers and stuff, I don't know. Yeah, I'm not sure totally how comparable they are and how flexible Rust will be. But I can't have been the first person to do this. In fact, there's some wiki. Oh, that's not what I meant to do. There's some wiki somewhere where he lists out versions of locks. Different implementations. I wonder if I can find it quickly. Is this not the right website? Or is my internet just not working? That might be the case. It's still streaming, so that's good. But for some reason, Chrome does not want to connect to the internet. But my point is, I can't be the only person to have done this and attempted this in Rust. So if I run into real problems, maybe I'll go look for a reference. Okay, so unit has, well, actually I don't need this. I don't think I need class name here. And so maybe I don't need this to be fields. I could just have this whole type be fields. Right, so this and unit is the empty one. And then a binary, and that has, hey, thanks for hanging out, Equilibrium. Yeah, thanks for the follow, and I hope to see you back here. And you can tell me what things I've done horribly wrong, what things I've missed in the book. All right, have a nice night, and Happy New Year if I don't see you. Okay. So I'm going to lose this export. So maybe I'll have a default export that I add to for each one of these. So I'll say like, get rid of these. Export default, oops. That, can I do that? No. Export const. Or actually, I can just make all these static members of EXPR. So that's what I'll do. So I'll say const class equals define AST node of, oh, I'm gonna have to loop through these first. Object entries of classes dot for each name and fields, right? And with each of those, what am I doing? I'm going to do this. Define AST node with base name, last name as name, and fields. Then I want to say EXPR, so I'm adding a static method to add a static, not method, member of the main export so we can access this constructor from elsewhere. expr base name equals class. Is that it? Might be it. This, I can use the fancy types that I just made. Okay, why did I do all of that? Because I'm going to loop through visitor. Or I'm going to have to construct visitor with each of these things. Right, okay. Well, that's fun. Okay. Let me get my tests passing again. And then I'll probably take a quick break. expr.unit is not a constructor, right? Because we are no longer exporting these things. I wonder if I can easily do this. Something like that. Maybe not there. Maybe I'll say const like that. Oops. Equals expr. So destructure those things. Does not exist. Unit is not a constructor either. So TypeScript is complaining, but also it's false. It's not correct in JavaScript or TypeScript. So I think I'm gonna have to set the type of expr like an index type to say expr can have arbitrary members who are all of type expr. Then they have their own arbitrary constructors. So it might just be any. Okay, but either way, it's not working. So expr base name. Oh, should not be base name. That should be name. Okay, my test passes now, so that's good. But I'm still getting this JavaScript error, certainly. So, how can I solve this JavaScript error easily? Or TypeScript error, I'm sorry. Definitely need that break. Think about this for a second. To do. We add arbitrary static members to expr with values unknown to TypeScript at compile time. Oh, you want to know something else really interesting? Huh. So token is a string here. If I take out this, does this fail? It does not fail. That's kind of miraculous. Somehow token is known to be a global? Or no, these types just don't even, we're not even using these types anymore, are we? Type is completely unused. Oh, that's very interesting. So actually, these could be arrays of strings. Okay, I'm gonna add another to do change to array of strings, since type information is useless. Now I'm thinking it wouldn't be quite so easy to just flip this over to TypeScript later. Like to output this as a TypeScript file later. If, you know, whatever. Okay. At least we get the ordering information back. That's good. Okay. Add arbitrary static members. Compile time. So they're unknown at compile time. So whenever we try to use one of them in TypeScript, we'll get a typer. How can we get around that? Basically, we want to say EXPR can have arbitrary static members of any type, and yeah, TypeScript's not going to be happy with this. Okay. All right, I'm going to take a break real quick, and I will be right back. I'm back. Okay, so we have two to-dos. Change to an array of strings. That one's probably more straightforward. Let's do that. Okay, and now fields is not this, it's just a string array. And fields here, fields here. And now obviously you're not happy because we don't need object.entries of fields. We only need fields itself. Fields.map, and then right, yeah. Okay, should be back to passing, hopefully. Yes. Back to passing. And okay, so we can get rid of this to do. Now, I want to fix this type problem. I might have to just look for TypeScript stuff. TypeScript static members on fields. My internet on this computer is refusing to work again. Let me check. But chat is working. Let me check something. Maybe ecosia.org is not working? What about google.com? Nope. I just don't like that. What about Chrome instead of Chromium? Okay, you're happy. What about duckduckgo.com? Okay, so apparently Chromium's just failing to comply. So that's fine. We can use Chrome. Okay, we want to say TypeScript static member of class. TypeScript typing with static members of class. That seems promising. Public static. So, okay, I didn't know that this was a special thing. So static members exist on... I didn't know that. The static members were part of ES6. Huh. I've never used that before. I thought you would have to say circle dot something something later. But okay. So this means maybe we have to generate... I'm not sure how we can do this. Because I basically want to say static s in string. So maybe this is not the way to go at all. Maybe instead I want to say export nodes, right, const nodes, and I can specifically say s in string is some sort of expr, and then in here I would be saying nodes at that, right? So that fails because now I don't need expr from expr, I need node. So let me call it node first. Or AST node. AST node sounds better. Let's try that. How do I rename a variable? Okay. AST node. That's sounding better to me for some reason. And then here we'll say AST node AST node AST node. Hopefully back to passing now. Back to passing, but now these are unhappy because they think... Right, so maybe it's like... A extends? I don't know how to do this. I want to say something like A extends expr, but that A doesn't exist anywhere. But if I make this a type and say type type what? Type AST node type. It's a terrible name, but let's try it for now. Okay, and now we make this, we can make generic, and now A exists, and we can say A defaults to any. And are you happy? Okay, you fail. Maybe I can say A extends expr here. And now I just need to say A here. Okay, that makes sense. Okay, and what? What? You're happy. Everybody's happy. Oh my gosh, it's a Christmas miracle. Or a New Year's miracle, I guess. Okay, so fancy type to allow arbitrary children of EXPR not known at runtime. Or not known at compile time. Okay, cool. That's good enough for me. Okay, now we can move on to the funness of implementing visitor. So where's that? I think we gotta go down quite a ways here. Oh. Yeah, there's all this stuff. Visitor, visitor, visitor. Okay, define visitor. What kind of test would we want to write first? It can visit some arbitrary tree. Or we can say just a binary XPR. Okay, let me go back down. Let me hop past this real quick to where he writes this printer. Okay. Class AST visitor implements visitor what did I call this? Did I export this? No, I didn't export it. Implements visitor from... Oh, did you get it at the end there? No. No. Whoops. I want to import visitor. Okay. Now, right, it's generic. It's going to return a string. And it implements print, which takes in an expression, which I also need to import. And it outputs a string. Right? Yeah. And then it returns expr.accept this. I think that will work the same in JavaScript. It implements the visitor interface. That means we need visit methods for each of the expression types we have so far. So we have the expression types we have so far. Oh, you know what I'm realizing is we're not going to get any runtime check or any compile time check that a visitor implements everything that it needs to. That's unfortunate. How could we solve that? I don't know that we can. Without reverting to the method that the author uses, which is to have this separate pipeline idea. Okay, let me write that note here. To do by generating the classes, the AST node classes at runtime, we lose compile time checks that a given visitor will implement a visit method for each AST node class. I don't see any way around this except converting to the same meta pipeline for generating the script file as Nystrom uses. That'll be something to think about. Okay. Did I save this? No. Okay. Back to passing because I'm simply not testing anything yet. Okay. So for right now, we can go on our merry way anyways. Because we'll still, even if we convert later to that method, we'll still be writing all these things by hand. So visit binary expression. Binary is the only one we have so far. We have expr is of type binary. I don't think we pulled that out yet. Oh, we did. So what type are you? You're of type any. Function refers to a value. So I think we want type of binary. I guess it doesn't know that it's a class. Not sure. But okay, return parenthesize. I don't think, whatever. I was thinking this test that the author is doing right now is printing to the console and then visually checked, but I probably want something that just constructs some data structure that I can test matches, you know, the structure I expect. Parenthesize expr dot operator dot lexeme expr dot left expr dot right. Okay, so that's the only one I have so far, so I will skip all of these. Actually, there's not that many. I might as well type them out here while I'm at this part. Visit, grouping, expression. Actually, now I'm curious whether, whatever. Visit, grouping, expressions, expr. You know, I think this doesn't really matter. No, it does, because it's I was gonna say, could I use expr there instead of type of like this particular one, which I don't actually have yet. Wonder if I can say AST node dot group. Yeah, you have no problem with that. So why don't I do that for all of them? I can at least do it for this one. Right, the problem is that if I just use group and I try to extract it here, will it be there? Yeah, I guess it will. Okay, so that was not actually a problem, but I thought it was. Okay. Right. Type of group. What does group do? Return, parenthesize. There's no way I'm going to spell that right every single time. Group. expr.expression. Visit literal expr. expr.literal. This is not what I want at all. expr is a type of literal. And I want to put that up here. I guess I might as well put unary up there. I know that's what I'm doing next. This will return. Oh, no, it's slightly different. If expr.value is null, undefined, I'm not sure if that translates from Java. Expr.value is null, return nil, and return, otherwise return expr.value.toString. Okay. Final one, visit unary expression. Return parenthesize operator.lexeme and .write. Okay. Of course, we'll have to implement parenthesize after visit unary expression. I don't know why we wouldn't write that up here. I'm going to prefer to write that up here. Name is a string, and then any number of expressions is like that, I think. So we have a new string builder. So this, in JavaScript, we just need a string. So we'll say, not const, let string. Actually, I think we're appending to it. So I might just do let output and make it an array, which is a string array that starts empty, and then I'll just join it at the end. That seems more straightforward to me. So I can push onto it and then join it. So, okay, output dot push left paren dot push. Oh, I can't chain it like he has here. Output dot push name this has an S in it, and I'll say exprs.for each expression output dot push expr dot accept this. Is this correct? Yes, because we're using an arrow function. I think that should be right. And all these parentheses should be this dot parenthesize, but we'll finish this first. Output dot push right paren and return output dot join empty string. Alrighty. That was an easy port so far. We'll have to implement except, obviously. We'll have to change these all to this dot. Okay. We have a passing test because it doesn't do anything. Because I never actually called it yet. So this is the main function that the author has written. So we'll just port this to TypeScript after this whole thing. So I think this is the end of the class. Yes. Probably move this out of the test function at some point, but that's fine for now. So first we make a new expr.binary. I have this code here. So why don't I grab this, throw it down here, and then system.out.println, we'll just do a console.log. Console.log. New AST printer. We called it AST visitor, but it should probably be printer. New AST printer dot print expr. Okay, so that's kind of cool. Now it's obviously going to fail instantly because we don't have accept. So that's good. So we have a failing test. So we can implement on the failing test. And then obviously this test is not a good test. We're just logging. We're not testing the result, but we'll at least get it to passing here and see what it prints out and visualize that it looks like what we expect it to do, what we expect it to, and then we can move on from there. So expr accept is not a function. So we have to make that a function on each of these classes that we're building. So let's scroll back up to where the author implements accept and make it happen. R accept visitor. Okay, so this is saying that in define type, inside the base class, we define the abstract accept. So expr should have a abstract function accept with R. I'm not sure that's how you write that in TypeScript. Accepts a visitor of R, and I mean, this is an abstract class. Can I have an abstract method? Apparently I can. So I've put it on the abstract class, and now I need to make sure that it's implemented. But it's kind of useless because, again, I don't have any compile time checks. So kind of being silly here, but I think at some point we will have to convert the AST nodes, convert this to a separate pipeline that generates this file, which will be a little obnoxious, but it'll just be better for coding. And we'll get to use the power of TypeScript instead of hacking it. Okay. So each of these things should have its own declaration for an accept method. Accept takes in an R, but we don't actually need to care about types here because we're not in TypeScript land. So accept is a function that takes in a visitor and it returns visitor.visit, and okay, so here's the spicy part, is that it's calling a specific function on visitor. So visitor call or visitor method name is this business. It's visit. Whoops. That is not dynamic. Visit, and then immediately class name, and then immediately base name. Okay, so that's the method name. So I can just use that here. And then simply this. Okay, that looks like a big complicated line now that I've finished it, so let's give it its own line. Okay. Now it has an accept function. Will it get further in the test? Yes. Visit unit expr is not a function. Right, I made a unit that the author didn't have. I made this unit expr that the author didn't have. So I will need to implement that in my visitor. Here. Not here. I'm going to do it down with all the others. Visit unit expr. expr is type of unit. Although we don't get any information about that. We'll return just unit. Okay, it's at the base of the tree. Visit unit expr is not a function still. Visitor.visit unit expr. Why are you not a function? I have just implemented you to be a function. Did I spell this wrong? Oh, you just passed. And you just printed exactly what I expected you to print. What was going on there? Oh, I was seeing a passed output. That looks much better. Okay. Okay. So now my next step will be to turn this console.log where we're reviewing it visually into a thing where we can check it with our brains. Which I think we can just say expect that to be, and we can just grab all of this. Right? And we got a pass. Okay. Wow. Well, that's exciting. And the obvious next steps are to implement all of the other... Where is it? It's way up here. It's somewhere around here. Right. Okay, implementing these will be easy. I don't have any tests for them at the moment, but that's fine. We have grouping, which gets an expression. We get literal, which gets a value, and we have unary, which gets an operator and a write. Okay. Cool, cool, cool. This is probably a good place, even though we didn't really implement something that has all of them in it. Actually, I wonder if I can... just grab this verbatim. Hold on. Or all, like very, very nearly verbatim. Let me just try this. I'm just gonna grab it for now. And it'll obviously be mad. New binary. We can get rid of expr dot. Okay. Cannot find name grouping. Oh, I called it the wrong name. It is grouping. Okay, and now can we just do the same thing, but with expr2? This should fail, but it should fail because it expects exactly what we got over here. Oh, that's awesome. Okay, cool. That's really neat. Okay, obviously, you know, to do extract this to a different file, but it's fine for now. And okay, we're done with the chapter. So let me commit what I have. I have some new files. And I'll take a quick look over it. This is my test. We can construct a binary thing, and then our AST printer visitor. This visitor thing is really cool. And I feel like I might actually understand it a bit now. Obviously, we can also extract these two different files. Okay. I have an abstract class. I have an AST node type, or an AST node with basically arbitrary type. Almost completely arbitrary. And I mean, I don't even know, because of this equals any, does that completely override that extends EXPR thing? Because any doesn't extend EXPR. I don't know. I would guess it's not very useful at all. But that's kind of what this to-do says, is that we're not getting runtime help, compile time help from TypeScript for any of these classes. Now that might not be a big deal depending on how much we use this stuff, but it's definitely at the very least kind of obnoxious. Okay. Right, so here's our definition. Here's some random types in kind of a weird place in the file, but that's fine. All right. That looks good. Define AST node, we make a bunch of strings, and then we use those strings in a class, and then we eval them. Looks good to me. So feat AST node classes and tests with visitor pattern. Cool. All right. I am gonna take, no, it's midnight. I should probably take off for the evening. Lurkers, if you want me to raid, speak now. Otherwise, you're on your own. I'm gonna glance at these challenges here, but I'll be signing off very shortly. And if you are lurking, I appreciate your company. Good to have you. We love the lurkers. Okay. These Bacchus Nauer form things are just syntactic sugar. Take this grammar. It's complicated grammar. Produce a grammar that matches the same language but does not use any of the notational sugar. Okay, so that's just repeating a bunch of stuff. So like we'd have to have a separate thing for this, which is recursive again. So like a comma separated EXPR. That's, yeah. Okay. I feel like I can do that. What kind of expression does this bit of grammar encode? Is this a period? For some reason it feels like it's in the middle of the line, but maybe I'm just tired. So identifier, oh, this is all one line. This is all one production. That's what was confusing me. What kind of expression? I'm not sure I understand what kind of expression. I mean, this is obviously a comma separated list in here, or a period, but it always starts with an expression. Yeah, I'm really not sure what that question is asking. Okay, it's like it's an expression for some language that only has identifiers and numbers. Is it a function call? Because like they're saying this is an identifier. Identifier or dot identifier. I don't know. Might be too tired to really figure that out. And also this being wrapped on multiple lines is not helping. And it's even wrapped when I maximize it like this. Let me try to make it as small as I can. Okay, so it's either this, which is either this or this. So it could be like number dot identifier dot number dot identifier, right? So I'm not really sure how to describe that. The visitor pattern lets you emulate the functional style in an object-oriented language. Devise a complementary pattern for a functional language. It should let you bundle all of the operations on one type together and let you define new types easily. Define a complementary pattern for a functional language where you can bundle all the operations on one type together and let you define new types easily. I'm not sure I understand. I mean, is that just kind of like a closure? Where you have a type that and a bunch of methods that act on that type? Again, might be too tired to really understand that. Okay, RPN, the operands to an arithmetic operation are both placed before the operator. Right. Evaluation proceeds from left to right. Numbers are pushed onto an implicit stack. An arithmetic operator pops the two numbers, performs the operation, pushes the result. Define a visitor class for a syntax tree classes that takes an expression and converts it to RPN. So, I mean, we basically did that, except we would need to be passing a stack around, I think, right? pagan.dev. Hi, RWX Rob. Hey, I actually want to show you something. Welcome to the stream. I'm going to check that out in a second. This is crafting interpreters. Whoops, wrong thing. This is what I want to show you if you watch what I'm typing down at the bottom of my screen right now. This is craftinginterpreters.com. I'm hitting enter. What I wanted to show you is that I'm using a thing you showed me a long time ago, which is I have WeChat running right now. It happens to be running inside of Emacs, but that's not the important part. I just use your script or the idea of pushing onto the WeChat FIFO, and I wrote a little Emacs thing to let me do that right from Emacs. Okay, but you had a question, and you told me about pagan.dev. So I'm familiar with PegN, or I'm sorry, I'm familiar with Peg. Dark mode does not like this site. Hold on. Okay. Yeah, so I'm familiar with Peg. But this is a notation for that. Yeah. So I'm really not using any parser generator or anything. This book goes through writing a scanner, and then shortly we'll be moving on to the parser. We were just working on building a tree up. So what you were seeing is, yeah, I'm happy to do it. So what you're seeing is just the author going over, you know, what context-free grammars are, and versus regular blah blah blah. So yeah, this is EBNF, some version of it, right? Like every paper you look at has a slightly different. Oh wait, you said eBPF. I don't know eBPF. But this is, oh, okay. Yeah, so this is something like that. Yeah. Well, I was actually just about to sign off, but I'm so glad you hopped over to my stream because I've been a long time follower of yours. Okay. This is a bunch of words I don't know. Oh, well, I know each word individually. And yeah. But I am dead tired, so I think I will have to say goodnight. And it's a pleasure to have you as a lurker. Yeah. So yeah, I'm doing this book, like I said, in TypeScript, and I'll be doing that for the first part where the author uses Java. Oh, and thank you for the follow. So I'll be doing it in TypeScript where the author uses Java, and then in the third part of the book, he flips to writing the exact same interpreter in C. And instead of using C, I'm going to be using Rust, which I don't know very well. Like I'm very bad at Rust. So that's the idea, is that, you know, yeah, it's, I mean, the online version is free, craftinginterpreters.com, and then you can order or print an ebook. Right, no, language is not important, and that's kind of the point for me, is like, well, a couple things. I did just start learning Rust as like a way, almost like an entry to just get me to stream. It's like, what can I do on stream? Well, you know, I've always kind of wanted to dabble in Rust, so I started learning it. The other thing is that I'd rather not implement it in C, because I don't care to learn C. Not that I particularly care to learn Rust, but I did C in college, and I just don't care to be really good at it these days. I might have chosen Go or some functional language even, although the concepts probably wouldn't translate too well. But anyways, my idea was, I'm writing this in TypeScript right now. I've got let's see here. Oh, it's broken right now. But I'm basically writing a REPL. It will be a REPL for this interpreter as a browser app. And then I was thinking it would be fun to compile that to compile the Rust version to WebAssembly, and then run them side by side, like the TypeScript version and the Rust version in the browser. And I thought that would be really interesting. Yes, I am familiar with this other book. I might check that out. But again, it's just like, yeah. It's all just having fun with it, and learning more about, in general, language design and language implementation and stuff. I have implemented an interpreter poorly. I have never implemented a compiler, so. Oh, I didn't know that, but it makes sense, right? Like, yeah. All that safety stuff, right? So, yeah. All right. Yeah. Good night, and thanks for popping over. And I'm definitely gonna check out your PegN thing. But okay. Good night, everybody. And if I don't see you, Happy New Year.